Welcome back. Problem 4-11. So statement is the load is supported by 4304 stainless steel wire that are connected to the rigid member A, B and CD. Determine the vertical displacement of 500-pound load if the members were originally horizontal when load was applied. Each wire has cross-sectional area of 0.025 square inch. So you can see this is DC rigid member and this is AB that are supported by this 4-wire DE, CF, BG and AH. And when a load of P that is 500 pound is applied when this wire is horizontal, clear? So you have to find the vertical displacement due to this load of 500. So let's start with the solution. First of all, we will find the force in each wire is wire ED, wire wire FC, wire GB, wire AH. How we will find? So we will draw the free body diagrams. So let's move and solve this. So internal forces in wire. So what we will do, we will take free body diagram FBD for AB. What is AB? AB is this rigid bar. So I will draw this bar AB. Clear? Let this is AB. So at this point B, we have a load of FBG. At point A, we have a load of FAH. Clear? And there is a load of 500 pound that will acting downward. The distance from this to point B is given as 1 feet, while this distance is given as 3 feet. I will show you over here. You can see this is 1 feet, this is 3 feet, this is your point A, this is your point B, and this is your point I. Okay, so we will find this unknown forces FAH and FBG by using equilibrium conditions. So what we will do is that we will apply equilibrium condition. Sum of all moment about point A is equal to 0 and taking the counterclockwise moment as positive. Now at point A, one moment is due to 500 and perpendicular distance is 3 feet and it will be clockwise. The other moment is FBG and perpendicular distance is this total 4 feet and it will be counterclockwise. Their sum must be equal to 0. So 4 feet into FBG, that is counterclockwise FBG, minus FAH, not FAH. We are taking moment about point A. So minus 500 into 3 is equal to 0. So from here you will get FBG will be equal to 375 pounds. Now you have this 375 pounds. You will apply another equilibrium condition that sum of all moment are, you can now simply apply this equation that sum of all forces along y direction must be equal to 0 and taking the upward force as positive. So there are three forces. One is this upward, the other one is this upward, and lower one is downward. Their sum must be equal to 0. So FAH is positive plus FBH, which is 375 minus 500 is equal to 0. So from here you will get FAH is equal to 125 pound. So these two forces have been calculated. Now we will move toward member DC and we will draw the free body diagram over here. So this is your member, this is your point D, this is your point C. At C we have upward force that is represented as FCF. At point D we have a force upward, that is FDE, and at this point H we have a force that will be now downward, and this will be FAH. FAH is in this portion it was opposite, and here it is taken as downward. Clear? Also distance between D to H is 1 feet, and from H to C this distance is 2 feet. So we will apply equilibrium condition. What equilibrium condition we will apply? So we will apply equilibrium condition that sum of all movement about point D is equal to 0, and taking the counterclockwise movement as positive. So about point D, one movement is FAH into perpendicular distance is 1 feet, and that will be clockwise. The second movement is FCF into perpendicular distance is 3, and that will be counterclockwise. Okay, so FAH into perpendicular distance is 1, and that is clockwise. FAH into movement about point D is equal to into 1, and that is negative because this is clockwise, plus FCF into perpendicular distance is 3. Their sum must be equal to 0. Now you can see FCF is FAH is 125. Clear? So we will write minus 125 into 1 is 125 plus 3 FCF is equal to 0. So from here you will get FCF is equal to 41.67 pound. Okay, we will apply another equation that sum of all sum of all forces along y direction must be equal to 0, and taking the upward force as positive. So one force is this, other one is this, and third one is this one. So FDE plus FCF, which is this 41.46, 41.67 minus FAH, which is 125. Their sum must be equal to 0. So from here you will get FDE will be equal to 83.33 pounds. Now we have all the forces in wire, in this wire, in this wire, in this wire, and this wire. So we will calculate the displacement. So for displacement, we know that general formula for displacement is equal to F into L divided by A into E. So for displacement of displacement in wire D, in this wire D, so if I write it, it will be D, FD, LD, AD into E. So FD is 83.33, so 83.33 into length. So length, you can see it is 3 feet. So I will convert it into inch. So 3 feet into 12 will convert it into inch, divide by area of each wire is given as 0.025, and E is 28 into 10 raised to power 6 given in the given data. So if you calculate it, it will be 0.0042857 inch. Similarly, you can also find displacement of point C, that will be FC into LC divided by AC into E. So FC is generally in this, which is FCF. So FCF is 41.67 41.67. So 41.67. Length is the same, 3 feet. So 3 into 12 will be converted into inch, divided by area is 0.025 multiplied by 28 into 10 raised to the power 6. So when you solve this, this will be 0.0021429 inch. Now you can, if you assume this DC member, so initially it was like this. This is your point D, this is your point C. Now after displacement, you can see point D is, this is the displacement, this distance is the displacement, which is represented as del C, del D, and this is the half of this. So you can take it like this, and this displacement is, let me correct it, this displacement is this one, and this displacement is del C. So you can see from this diagram that if I plot, if I exceed it using dotted line, you will see that this is the same as del C, and this is equal to, this distance will be equal to 0.0021429, while del D is 0.0042857. So what if I join this point with this, clear? So we are interested to find out the deflection of this point H. So let this H point is at a distance of 1 feet. Here this is 1 feet, and this remaining is 2 feet. And this was your original point. Sorry, not this point. This point is your H point. Let me correct it. This is 2 feet. This is your point H. Clear? Now the H point will cover this displacement. And this total displacement is del H. And this will be equal to del C, because this distance is del C, and this portion is del H dash. So how you will find this del H dash? So you can see that I will show you this. If you take this as a right angle triangle, clear? So this del H, this distance over 2 feet will be equal to this distance, which is again this divided by total 3 feet distance. I will explain you. We have two similar triangle. One is this one, clear, and other is this one. So their side ratios will be same. So del H dash over 2. I will explain it again. This del H is this one divided by its base, which is 2, is equal to this height, which is again this or this divided by 2 divided by its total length, which is 3 feet. I hope it will be clear. So 0.0021429 divided by 3 feet. So from here you will get del H dash will be equal to 0.0014286 inch. Okay. So total, we know that total displacement of point H is equal to del C, which is equal to 0.0021429 plus del H dash. 0.0014286. So you will get total displacement of point H comes out to be 0.0035714 inch. Okay, so this was for member DC. Clear? We will move and we will find that this, because now you can see this point A is attached with this H, so this point A will also move downward. So our focus will be now on this beam. So let's draw this beam and also we will find that. So let this was the, I will choose another color, let this was the beam. Clear? This is point A. Clear? And we will find displacement. Okay, so before that I will go and we will find the elongation displacement in this wire AH and this wire BG. So how we will find displacement? So displacement of AH wire will be equal to FAH into length of AH divided by area of AH into E. So FAH, which we calculated above, FAH is 125 pounds, length is 1.8 feet. So let me put the values. FAH is 125 pounds, length was 1.8 feet, so 1.8 into 12 will be converted into inch. Area is 0.025 into E, which is 28 into 10 raised to power 6. So displacement of point A with respect to H will be equal to 0.0038571 inch. Okay, so this is displacement of point AH. Now total displacement of point A is displacement of point H plus displacement of point A slash H. I will explain. You can see this point H will move downward. Clear? So this displacement is point H and this displacement of point A with respect to H. So total displacement will be this one, point A. So you can put the value 0.0035714 plus 0.0038571, and that will be displacement of total displacement of point A is 0.0074286 inch. Similarly, displacement in wire B is equal to FBG into LBG divided by area BG into E. So FBG is 375, length is 5 feet. So you can put the value. So FBG is 375 pounds, length is 5 feet. So 5 into 12 will convert it into inch. Area is 0.025 into E is 28 into 10 raised to power 6. So from here you will get 0.0321428 inch. Now this is the displacement of point B. So if I draw the beam, this was initial the beam, this is your point A, this is your point B. At a distance of 1 feet from point B, there is a load of 500 pounds. So at a distance of 1 feet, there is a load of 500 pounds. Clear? Now what we have calculated displacement of point A, and this is displacement of point B. It means displacement of point A is larger. So let this is the displacement of point A and this is the displacement of point B. Clear? I will show. This is your displacement of point B, which is 0.0321428 28. This is the displacement of point A, which is 0.0074286. Clear? And due to this load P, this distance is 1 feet, and this remaining distance from A to B is 3 feet. So I will remove this force temporarily, because we know that at this point we have a load of, I will show it over here, P is equal to 500 pound. So you can see that if I draw a horizontal dotted line, so at this point this is same as del B, and if I connect this point with this, if I draw vertical straight line, so you can see that this point, this is the total displacement due to load P is equal to 500, and this will be equal to this del B. From this to this is del B, and this is del L dash, and let the total displacement from here to here, this is equal to del L. So del L is equal to del B plus del L dash. How we'll find this del L dash? So again you can see that we have two similar triangle. One is this triangle and the other one is this triangle. Okay, so by using similar triangle we will find this. So sigma L dash del L dash over 3, del L dash over 3, because this is at a distance of 3 feet. Del over 3 is equal to 0.0247143 over 4. Okay, so I have, what I have drawn is 3 feet, 3 feet at point B, at point A. So point A is 1 feet, 3 feet. Let me check it. Point A is this one, AH. A is this one and B is this one due to load. So point A we have this and B we have this. Point A is at a distance of B is 1 feet, and this is 3 feet. Okay, so del L dash over this 3 feet, 1 feet is equal to this over total L. Okay, so del L over 3 feet is equal to, okay, so del L dash over perpendicular distance over here is, I have then this is point B. At point B we have 0.034. Okay, so I found the mistake. The mistake is in this diagram. So you can see del A is small and del B is larger. So we will modify this diagram again. So it will take time. So let me correct it. In this way you will have a clear idea and understanding about this, and you will learn it. Okay, so this is your sigma B. Clear? This is your del B, sorry, del B. And del A is 0.05. Let's say this is your del B. This is a very small value. This is del, sorry, A. And that is equal to 0.007428. So if you draw horizontal line, so you can see that in this portion, this will be also del A. Again, your new displacement is this. So if you join it with a straight line, so you will get this. I'm sorry for that. Now you can see load due, this is total del L. And in this del L, you will see this portion is del A. So I will correct it to del A plus this portion is del L dash. Okay, so from we have two right angle triangle. One is this one and the other one is this one. So first I have written del L dash over 3 feet. So del L dash is this one over 3 feet is equal to this distance, which is 0.02714 divided by total 4 feet. Now it's correct. So from here you will get del L dash is equal to 0.0185357 inch. Clear? Now you know that del L is equal to del L dash plus del A. So it is equal to 0.007428 plus del L dash is 0.0185357. So from here you will get del L is equal to 0.0260 inch. So this is the displacement of our point where the load of P is 500 pounds is applied. So I hope you have enjoyed this video. Again, if you have any question, you can ask me in comment section. Thank you.